Hey folks, welcome to another set of Intro Chemistry video notes. In today's lesson, in the last lesson for Unit 1, we're going to learn a little bit about trends in the periodic table and how to draw Lewis symbols. My goal is for you to be able to recognize the trend in valence electrons and element properties on the periodic table and how to represent elements with Lewis symbols. Let's get started. As you might remember and have figured out from the last lesson, elements that are in the same group on the periodic table tend to have the same number of valence electrons. This is true for groups 1, 2, and 13 through 18, known as the representative elements. We also sometimes label these groups 1 through 8a. For example, the alkali metals in group 1 all have one valence electron, as you can see here. The alkaline earth metals in group 2 all have two valence electrons. The halogens over in group 17, or 7a, all have 7 valence electrons. So that's the first periodic trend you should know. Elements in the same group have the same number of valence electrons. Another important trend, which will help the others make more sense, is that elements in the same row, or period, all have the same number of energy levels, or shells of electrons. This means across a row, the elements are relatively about the same size. The rest of the trends we're going to learn about are all going to depend on remembering the trend for atomic size. As you move from top to bottom in the periodic table, atoms get larger. Why do they get larger? Well, that's easy. Each space we move down, we add a whole layer of electrons. That one should be the easy one to remember. Atoms are like onions and have layers. The first row only has one layer, the second row has two, the third row has 3 layers, and so on and so forth. The tricky one to remember is what happens within a period. Since atoms in the same period have the same number of electron layers, they're relatively close in size. However, as we move from left to right, the atoms get a little bit smaller. Why is that? Well, since the elements are ordered by atomic number, as we move from left to right across a period, we add protons. More protons means a more positive nucleus. A more positive nucleus means the nucleus will more strongly attract the layers of negative electrons in closer towards it. So, from left to right, atoms get a little bit smaller because the more positive nucleus pulls those electrons in tighter. The rest of the trends are easy if we can remember atomic size. As atoms get smaller, their valence electrons are closer to the nucleus and therefore will take more energy to remove. This is called the ionization energy. When atoms share their electrons in a covalent bond, smaller ones have their nucleus closer to the outer layer, so they can pull these shared electrons from the bond closer to them. The strength of atoms to be able to pull shared electrons toward them is called electronegativity. And the closer an atom is to having 8 valence electrons, the more reactive it is. Let's look at those 3 a bit deeper. Ionization energy increases as you go up into the right on the periodic table. Since the atom gets smaller up and to the right, it becomes more difficult to remove a valence electron from that atom. In other words, it has a higher ionization energy. It takes more energy to remove that electron. The same idea goes for electronegativity. As atoms get smaller up and to the right, the nucleus is closer to the shared pair of electrons that's in a covalent bond. So the nucleus of a smaller atom can pull those electrons in with more strength. That's known as electronegativity. Fluorine is the most electronegative element, and chlorine, nitrogen, and oxygen are also among the most electronegative. The trend for reactivity has 2 parts to think about. The goal of any atom is to look like a noble gas. It could do this by moving to the right or moving to the left, gaining electrons or losing electrons. To look like a noble gas, it has to have 8 valence electrons. If you're a nonmetal on the right side of the periodic table, you prefer to gain electrons to get to that full octet. Smaller atoms have an easier time gaining electrons, so as you move up and to the right, the nonmetals become more reactive. Metals, which are to the left of the zigzag line of the metalloids in the periodic table, find it preferable to lose electrons and go backwards on the periodic table until they look like a noble gas. Larger atoms have an easier time losing electrons because those valence electrons aren't held on as tightly by the nucleus because they're further away. Therefore, metals become more reactive as you move down and to the left on the periodic table. Here are all the trends summarized and how you should have them labeled in your notebook. Last but not least, let's talk about Lewis symbols. A Lewis symbol is simply the chemical symbol of an element with dots around it that represent its valence electrons. You have a chart of Lewis symbols of the representative elements to glue into your notebook. But in case you ever need to draw one, here's how you do it. Write down the chemical symbol, figure out the number of valence electrons that element has, then draw dots to represent those electrons in the 4 regions, up, down, left, and right, around the symbol. Put the dots, one in each region, until you get to the 5th electron. Then you can start pairing those electrons up. Lewis symbols are important for understanding how an atom will bond together, which is what our next unit will be all about. So it's a good idea for you to get a firm understanding of Lewis symbols now. For example, if I were to draw a Lewis symbol of bromine, which has 7 valence electrons, I'd write down the symbol Br. I would place 4 dots around it, one in each region, and then place the remaining 3 electrons by pairing them up with a lone electron. When I'm done, I should have 3 pairs of valence electrons and 1 single lonely electron who's ready to pair up with somebody at some point. Well, that's all for today, folks. As always, if you have any questions, ask.